Hello, my friends, and welcome to another episode of Golden Droplets, a series of webinars intended to close the gap between academic and industry. In today's episode 61, we are exploring a powerful tool developed by mine geologists called Drill Hole EDA for geological modeling. This free application is designed to simplify the integration of geological data with assay results, creating a unified table that helps you quickly determine which rock groups, soil horizons, or geophysical signature are most likely associated to your potential mineralization. So, once again, Golden Droplets, episode 61, joy. So, before we can start using the application designed by this group, we need some data. So I prepare here 6 Excel tables with data from drilling program, soil sampling program, and a geophysical survey. So we can test 3 different methods with this application. They all work fine, but I will encourage you to stay until the end because I will be presenting ways to obtain the same results using artificial intelligence programs. So let's jump on the Excel tables. So here are the data that we're going to be using. First of all, remember that each of these tables, this one here and this one here, each one should be saved as an independent table in a CSV format. Okay? That's the way the application uses the data. You can have as many columns as you wish. As you can see, there are no coordinates in this drilling data. They are just comparing the tables, the geology with the assay, based on the sample interval. So in this case, like is usually on drilling programs, the table for the geology will be shorter than the table for the assay results, okay? Because, for example, here we have an interval that goes from 1 to 5 meters, which is a basalt, but the same interval was sampled every meter. So we have more data from the assays than from the geology. The other table we will be using is geochemistry sample. In this case, table will be the same because we sample the same interval that we describe. So we will have the same amount of rows on both columns. But in this case, we're having a series of soil sampling from 1 to 7, and on each hole, we sample 3 horizons, A, B, and C. And here are the results for the same samples, the same intervals, for gold and copper. So in this case, the objective will be to figure out which horizon is the best to detect the anomaly, the element that we're looking for. In the third case, we have the same amount of rows because it is the way geophysics and geochemistry works. We have different geology, like in the terrain with a soil coverage, and there is a quartz vein and then an andesitic flow. And we are testing 3 methods: magnetics, gravimetrics, and IP. These numbers, these values are totally random. They don't represent the usual result for this kind of survey. We just want to show you how the system works, okay? So if we go back now to Dreamlit, the Drill EDA program, this is the screen that you get. We are going to upload the tables now. First, we're going to upload the lithology, or I call it geology. Okay, so for the drill, that will be geology. And then I will add the assays. I remind you, these are CSV, very simple files. Don't worry about this text because we're going to fix that right now. So down here, we need to select the columns. First, we select the hole, Then we select from the two, the geology as the lithology. And then for the column of the assays, we select the whole from is from, that's okay. Two, and now we get a new couple of lines. Here we're going to select which elements are we interested in. And here, and this is very useful, you can add, it's not a cutoff, but the value that below that you will consider that the sample is not interesting. And while we're doing this, you already see that the program generated the original table of lithology, you can see there, then the values, 0 values for the gold, okay? So let's say that we want to use a cutoff of 5, just for that, okay? And the program immediately generate the combined table, okay, with all the data, and you can download this to your computer and work better. Now, you also see here that there are 3 types of rock, the granite, the granodiorite, and the tonalite, which are basically the same rock for our purpose. Maybe there were 2 or 3 different geologists working on this drill, and they use different names, but they are the same. We have here basically only 4 lithological types. So this is very useful. Right here, you can click on Combine Lithologies, okay? And we will say that we will have 4 main geologists, and we're going to generate this group. So first, we're going to select this granite, granodiorite, and tonalite, make it in one group, and we'll call the group felsic rocks. The next group will be soil, and we will call it soil. The next group will be basalt, and we will call it basalt. And the last group, we'll call it andesite, and we will call this andesite. And we click here to combine lithologies. So what happened now, you can see that all these previous rock that had different names like tonalite or granodiorite, they are all called felsic rocks. So this is something very useful because it saves you a lot of time. Now, based on this cutoff that you use here, the program will then determine which is the lithology that is the probable source for the ore. And in this case, it has identified the felsic rocks with a mean for gold of 7.14. All the other lithologies are possibly waste because they are below the 5 part per million or part per trillion, whatever, that we use. If you click here, you will have the statistic, the descriptive statistic for this group. And again, you click on any of those, you will get those statistics, and in every case, you can download this data as a CSV. Wonderful, perfect. We have already an idea that the felsic rock is our main target. But also, the program has a visualization part, and you can generate scattered plots. Like, for example, I'm going to make a scatter plot between the copper and the gold, and I will filter by rock type, and that's it. And I will see here the correlation, the scatter diagram between copper and gold. You can see there is some kind of a positive correlation between them. This is a good graphic, but the graphic that I really like from this application is the box plot. So if we select box plot, and we will use gold, categorized by rocks, And we leave the rest here. Here is what we get. This is a very useful graphic. It clearly shows that if we are looking for gold, we need to be looking mostly for felsic rocks. These are the ones that have the highest concentration or the element in general for the whole area. So this is a very useful tool. And this new lithology analysis, they just added like yesterday, okay? And it generates lithology summaries and another graphic representing the sequences. So you can see that salt remains the same, basalt more or less the same, granite changes, then it's andesite, etc., etc. So this is what you can do with data from the drill hole. Now let's go back and delete these two files. And we're going to put the soil sampling. So first is the soil geology, and then the soil assays. And again, we're going to go back here and check. Hold is hold, from. I hope they will change, they will improve this because they should be able to do this automatically. Lithology will be geology, then the assay, hold is hold, from is from, to is to, and we will organize by gold. And again, we're going to use F5, not F5, it is soil, let's use 2 gram per ton. There is no need to combine lithologies here. And if we go to data processing, the program already created the 2 tables and the unified tables. And considering this cutoff that we use, is recommending saying that horizon B is the possible ore. It's the one that has the highest value of gold. So this should be our target of exploration. If we go to the visualization and we use the box plot, so let's say gold rock without touching anything like this, it's clearly showing you that the B horizon is the best to sample this method. Now, let's see our last example, which is the application of this to geophysics. So again, we enter the geology for geophysics and the results from geophysics. So hold is hold, from to lithology is our geology. And for the results, we have hold, from, to, and then we have the different targets. We can select magnetics, gravimetrics, or IP. I just select magnetics. And if we go to data processing, you can see the magnetics are between 1 to 20. So let's set the cutoff for 5. Okay. And when we look at the results, we see that the possible ore source will be the quartz vein, which has a mean of 7.63 magnetics. If we go to the visualization, and we put magnetic rocks, etc., we get a clear picture why the magnetic method is the best for detecting the quartz vein, and it's logical the quartz vein is our target. So this is the application, but don't go away because I promise you that I will show how you can do almost the same analysis using ChatGPT. So let's go to my screen, and the program that I'm going to be using is called Perplexity. Of all the ones that I have tested, I tested Gemini, ChatGPT, a cloud, PO, etc. Perplexity is the one that works the best. And I already did the test. I'm going to just show it to you how it works. So we start with a command, please combine the two tables into one and show the results. And I added the geology for the drill program and the assay for the drill program. And it created the combined table, no problems at all. And even did a little bit of explanation. Now, I want to combine lithologies. I say combine the result from granite, granodiorite, and tonalite in one group called the fossil rocks and reproduce the table again. Again, in seconds, he did that. Same results. Okay. Then I said generate a box plot for the gold result, group it in accordance to the geology. And here is where the application is better because it explains how to do it, explains the results. Okay, he said the result will be a soil, likely a narrow range with few samples, the basalt, wider range, andesite, narrow range, felsic rock, potentially the wider range and highest median, combining data from the three types of rock. So it's telling us that, yes, felsic rock should be our target. But when I asked, can you show the box plot, it could not do it. I mean, it probably could do it, but I will need to download some Python application. So you get same result. But there is another program called Julius.ai, which is one of the best methods to process data. And once you sign in Julius.ai, you start a new project, you upload your data, which in this case could be Excel files, doesn't need to be CSV, but I leave it there. And I gave the same command. Please combine these two tables into one and show the result. It shows me the Python, how we do it, and it generates the combined table. And right here on the right, it's giving me messages about the files, the characteristic of the file that I uploaded. So next I said, and as you can see, I didn't combine here anything because these are the source sampling. I say generate a box plot for the gold results, group it in accordance to the geology, so horizon A, B, or C. And because it's using Python, it gave me an easy to follow graphic just saying that yes, the horizon B has the highest concentration of gold, so these should be our targets. It also can do an interpretation of the box plot. So you say interpret the box plot and it gives you this. So as you can see, you can use Julius to get same results as this other application. I'm sure it's going to become better because they are adding new stuff all the time. So as you can see, you can use the application or Julius.ai or Perplexity and get the same results. I am absolutely sure that the application will become better because they are adding new capabilities. But again, it's a great save of time because it allows you to combine tables that may be similar in size. In that case, it's not that difficult. But in the case of the drilling specifically, that is perfect because you have 4 or 5 lithological types with 5,000 results. So this would combine these two tables into just one. And again, you can always download that new table into your computer and continue your work. Well, that will be all for Golden Droplets episode number 61. I hope you find this interesting. Don't forget to like, subscribe, and I'll see you in Golden Droplets episode number 62. Have a great day.